Hi all and welcome you all to the yet another video on quantifiers. In our previous video in quantifier, we would have explored understanding the quantified statements to be written in symbolic form. But if you remember, the examples that we dealt with were with one quantifier and with one variable. So let us look into an example where we have more than one quantifier and more than one variable. So let's check out with this one example of writing the statement in symbolic form. So the statement given here is everyone who likes fun will enjoy each of these play. So when you read this statement, somewhere you get a clue that there is a quantifier everyone and there is another quantifier each of these play. So we can associate a propositional function to these statements now. And how should we do it? So let us now pick up the first propositional function that strikes my mind. So let us now consider our propositional functions. Suppose I choose my x to be a person. So x likes fun. So here I might take likes fun to be my predicate and x is a variable. So it is the predicate subjected to the variable. Next, each of these plays. So I now consider a propositional function. Y is a play. So now I denote this as a propositional function with the predicate P and the variable Y. Now see how these two are being connected. In the statement we would see that there is a property connectivity enjoy. So everyone who likes fun will enjoy each of these plays. So now I would consider my propositional function as x enjoys y. So how would I write my propositional function? My propositional function will be now based on e of x comma y. So it is a two predicate function where you see that the predicate is one but the variables are two connected. So if we would like to write in a symbolic form, it would be always better if I am able to write or rewrite the above statement. So how should I rewrite the above statement? So when I rewrite it, it becomes easy for me to symbolize it. So how should I rewrite the statement? So since it is every, we very well know that any statement with every could be rephrased into conditional statement. Yes. So now let us try doing it. So the rephrased statement could be written as for each x, if x likes fun, and for each y, if y is a play, then. Now this is important. If then is important. X enjoys y. I hope you people are able to connect it, right? So now with this rephrased statement, we can now symbolize the statement, right? So how are you going to symbolize the statement? It is for each x could be written as for every x. Yes. And also you observe for each y. So when I say for each x and for each y, these two quantifiers have to be mentioned in the first itself. And now Since it is been evident that I have written in if-then statement, then I now have to look that x likes fun, that is nothing but L of x, and for each y, and for each y, then x enjoys y. So the propositional function is e of x comma y. So I hope you have understood that how we should identify from the given statement the propositional functions with more than one variable, and hence you'll end up with more than one quantifiers too. And let us now look into another example where you can understand symbolization of more than one quantifier and more than one variable in much more clarity. So now let us look into the next example where we would express our given statement into logical expression. Everyone who is healthy can do all kinds of work. So when you read the statement itself, you get a clue. Everyone seems to be one quantifier, and all kinds, all looks like another quantifier. Let us now write the proposition function. So here when I just read the statement, we can consider x is healthy. X is healthy could be one proposition, so I can mention it as h of x, and I am also able to identify that y is a kind of work. Y can be considered as a kind of work. So how should I define this propositional function? I'll just define it as some keyword k of y, right? And now here I would observe that one who is healthy can do. So what connects these two propositional function is this. So I now write x can do all kind of work with y, right? Can do all kind of work, all kind of work with y, right? So how do I interpret this? Do, can do, so I just name it as d of x comma y. So as I was mentioning earlier, that any statement that is been given to you, if that is been rewritten in a simpler form, then it becomes easy for us to symbolize it. So now let us just look how should I symbolize the given statement. So for all x comma y. So you can also write for all x and for all y, or else you can write together for all x comma y. X is a healthy person, is a healthy person. And here again to be noted is I have used a quantifier everyone, right? And I have to be now consciously rephrasing this statement in a conditional form, that is if then form. So if x is healthy person and for all y, if y is a kind of work, then x can do all kind of work. Right? So now it is quite evident that how this could be written into symbolic form now. So now I try symbolizing it, and here when I symbolize it, I write it as for every x, for every y, right? X is a healthy person is h of x, and y is a kind of work is k of y. Then x can do all kinds of work along with y. So it is d of x comma y. So I hope you would have understood this example also. Now let us see one more example where we make use of the existential quantifier, or where we make use of few sum. Thank you all for watching this video.